Welcome to this video on A-level maths mechanics for velocity time graphs. Let's understand and interpret velocity time graphs. So in this example, a car accelerates from rest to 20 meters per second in 25 seconds. The car then travels a further 45 seconds at 20 meters per second. First thing we need to do is draw a velocity time graph for the car. So on the vertical axis, I will place velocity measured in meters per second, and then I will place time on my horizontal axis measured in seconds. Note that it says that the car accelerates from rest. So at time t equals 0, the velocity is 0. Here is the car accelerating here, and it will accelerate over 25 seconds, and it will accelerate to a velocity of 20 meters per second. So I've put in critical points on the axes of the graph. It then says that the car then travels for a further 45 seconds at 20 meters per second. So the car then continues at a constant velocity for a further 45 seconds. So in total, that would be 70 seconds. So there is my velocity time graph for the car. Next, we're going to find the initial acceleration of the car in its first 25 seconds. Well, to work out the acceleration of the car, we need to find the gradient of the velocity time graph. So the acceleration, A, is equal to the gradient. I'm going to use the letter M for gradient. And we know that's equal to the change in Y over the change in X. So the change in Y, or the change in the vertical axis, divided by change in X, the change in the horizontal axis. So I'm just going to put a Y on my vertical axis and an X on my horizontal so you can see what I mean. So in the first 25 seconds, the change in the car's velocity is 20 meters per second, and it does that in 25 seconds. So the acceleration of the car is 0.8 meters per second squared. Next, we'll find the total displacement of the car after 70 seconds. To find the total displacement of the car, we find out the area under the curve. So I'm just going to highlight this in a sort of orange, the shape of this area. So the area under the graph is the total displacement, and you can see that this area is a trapezium. Okay, and a trapezium has parallel sides, and we can see this side here has a length of 70, which relates to 70 seconds, and this side here has a length of 45, which relates to 45 seconds, and it has a vertical height of 20, which relates to the velocity of 20 meters per second. So the total displacement is equal to the area under the graph, which is equal to the area of the trapezium. And the area of the trapezium formula is the average of the parallel sides. So that's a half times 45 plus 70 times the perpendicular height, which in this case is times the 20, which represents the velocity of 20 meters per second. and this value is 1,150 meters. Thanks for watching this video on velocity time graphs. If you'd like to learn more about this topic and see how we solve questions where we compare the velocity time graphs of two objects, then please join kippersconsultancy.co.uk and meet other students and tutors, have your harder questions answered, and build confidence and access higher grades. Thanks for watching. Bye.